Hi, my name is Abigail Chiu, and welcome to this tutorial on performing NMR relaxation via peak height analysis, or RH, and perturbation plot, NP, in the POKY suite. In this tutorial, we will go over how to use RH to fit peak heights or volumes in a series of spectra to a decaying exponential, and NP to create perturbation plot on your hetNOE data. So here I've already opened my data for relaxation analysis. In my example, I already have assignments in my data, but if you have no assignments, you can still perform the analysis using arbitrary assignments, like assigning your peaks 1, 2, 3, 4, 5 to find any residues that stands out. So to demonstrate how to do arbitrary assignments, I will use this spectrum right here. First, you need to pick some peaks. You can do that by using iPick or apes, or just use F8 or 33 to change your cursor mode to find add peaks. So that cursor mode is this button right here, or you can type 33 and that will change your cursor mode to be find/add. I'm just gonna drag a box here and just select some peaks, and then you can go run the arbitrary assignments by typing capitalized FA, or go to POKY perturbation analysis, and it's the first one at the top, assign NHSQC arbitrarily. So then it's going to ask you for a prefix and assignment. I will just stick with Z, but you can put any letters or words you like as your prefix assignment. So then you get an arbitrary assignment result saying that 61 peaks have been assigned arbitrarily. Click OK. You can validate that the peaks that you picked are correct by changing your cursor mode to zoom in. So it's this button right here. Draw a box to zoom in. You can also make the labels bigger by doing Control M to make it bigger, Control N for Nancy to be smaller. You can also make your X's on your peaks to be bigger as well by doing Control K to be bigger and Control J to be smaller. So this is an example as to how to do arbitrary assignments. And then from here, you can continue on and running your peak height analysis. So because I already have assignments, I do not need these arbitrary assignments. So I'm just going to delete them and just Control D for now. And now, once you have assignments, I already do, you can open the dialog by going to POKY, perturbation analysis, and it's the fourth one down called peak height analysis, or you can also type in a 2-letter code, lowercase RH. So in this dialog, you have different options to get your peak height for analysis. You can click on this drop-down menu. So the default is going to be heights at same position in each ppm, which means that it's going to take the spectrum heights from the same ppm position in each spectrum in this mode. There are other options as well, such as heights at assigned peak positions if available. What this will do is that it will take a data value at the ppm position of the selected peak if there are no assigned peak available in the spectrum. It's also heights at assigned peak positions only, so it will only take assigned peaks in the spectrum and will leave the spectrum out of the fit if there are no assigned peak. And then there's fit heights at assigned peak positions only, volumes of assigned peaks only, so that this will take the volumes, the peak volumes instead of the heights in the fit. Then there's sum of a box for selected peaks, and then notes of assigned peaks only. You also have different fit modes. There's traditional exponential, T exponential, and SEA HSQC or TROSY exponential. So in this example, I'm just going to be using the default modes, heights at same position in each spectrum, and traditional exponential for my fitting. Then before I do any analysis, you need to go to setup to choose the spectra that you want to take the peak heights from. So in this dialog, you can specify the time parameter on the right over here for each spectrum, which is typically your mixing time. If the spectrum name has an integer number in it, it will take the initial number in your spectrum name as the initial time parameter. So as you can see, my first numerical value here is 10. So that's what it's going to take as my time condition, time or condition. And you can also adjust the number of trials here for error estimates as well. This number of random trials is the number of times to add a Gaussian distributed random error to each height and calculate a fit for the perturbed heights. For more explanation as to what that is, you can click on the help button right here, which will bring you to the Sparky manual online and go to the relaxation fitting section. So to begin, I'm just going to select some data here. You can also select all of them if you want, or deselect all of them if you want. You can also filter by specific keywords in your spectrum name if you would like. I'm just going to select some of them and then click apply and OK. So now that it's set up, I'm going to select all the peaks here in my spectrum right here, Control A to select all of them, and then click update to do that. You can also just select one peak at a time if you want by just selecting one peak and then clicking update to add that result to the result box. So each line here will show the peak assignment and the sequence of heights in the selected spectra at the position of the selected peak. The sequence of heights is fit to a decaying exponential equation, which I chose to be traditional exponential. An error estimate is given for the t decay value right here. If you double click on the list line, the sequence of heights or volumes and the best fit exponential is plotted. Now, if you were to double click on a data point in the plot, it's going to show you the peak in the corresponding spectrum. If you want to save this data, you can click the save button to save the fits to a file. And then you can also append it by appending the list to a file as well. The clear button will clear all entries from the list. You can also delete individual entries by selecting them and then pressing the delete button on your keyboard. The backspace button will not work. Then you can also save it as a JSON file with the JSON button, and the help brings you to the Sparky manual online. You can plot your data, plot your TDK data by clicking the plot TDK button, which will give you a plot like this. You can also do plot 1 over TDK, and it will give you a plot like so. You can also plot heights by residues to do an intensity analysis by residue. So do note that this function is restricted under 15 spectra. And another option to do is the plot heights by spectrum function. This is restricted by under 15 residues. So if I were to click this button right now, it's going to say that, give me an error message because I have more than 15 residues in my result list here. So what I'm going to do is I'm going to clear my list, go back to my spectrum, select some data, and you can select multiple by holding the shift button and then selecting multiple peaks. So then I'm going to click update to get my results here. And then I'm going to click on the plot heights by spectrum, which will be allowed to give me the result here. So this is what it would look like. Now I'm just going to close these because I don't need them there. So the last button here is the NMR button, which is an open source software to analyze NMR relaxation dispersion data of either CPMG or R1P dispersion experiments. So this is the end of the tutorial on how to use the peak height analysis dialog or RH to fit peak heights or volumes in a series of spectra to a decaying exponential. So to start my perturbation analysis, I have already opened my data to create my perturbation plots. Do note that you will need assignments to do this analysis. If you don't, you can do arbitrary assignments. Next, to open the program, you can type lowercase np or go to POKY, perturbation analysis, and it's the second from the top, NMR perturbation plot. This will open up this dialog right here. You have places to select your spectra, change the title of your plot, the X label, the Y label, change your observables, B factor and B factor for glycines. You can also choose to use absolute values and decide which data to apply it to. And you can also change the color for your gradients. So in this example, I'm gonna change my spectrum first. Reference and hetNOE. I'm also gonna change my observables. If you scroll down, you have options. I'm gonna choose data height ratio, change my Y label accordingly, and then click Analyze. This will give you the results in this text box here. Then go to Plot the data, and then here's your plot. So once you have this plot, you can export the data. You can view it in PyMol, so which is what I'll do now. I'm gonna pick the PDB that it relates to, open. So this message will pop up that it's gonna launch PyMol. It should automatically already load the molecule for you. If it does not launch correctly, the command is in your clipboard already. So click OK. So great, it loaded for me, and that's the structure. Next, another thing on the list is you have this extra button. This allows you to open another dialog and do another analysis if you want to keep your current data. And lastly, you have this JSON button, which allows you to save the data as a JSON file. This is the end of the tutorial for performing NMR relaxation via peak height analysis and perturbation plot in the POKY suite. If you would like to learn about doing NMR relaxation via POKY Notepad scripts, please feel free to check out that video. Thank you for watching.